Students, good morning. Today I will teach you the KNN algorithm, that is K nearest neighbor algorithm. It is one of the popular and simplest classification and regression algorithm used in machine learning. This KNN algorithm can be used for both classification and regression. Okay, can be used for both regression and classification. Okay, and this algorithm mainly depend on memory to store all its training data. So it can be referred as memory-based algorithm or instant-based algorithm. It is commonly used for pattern recognition, data mining, financial market prediction, intrusion detection, etc. etc. Defining K. The K value, the K in an algorithm depends how many nearest neighbors will be checked to determine the classification of a specific query point. Okay, depends on the value of K. We should compare the nearest neighbors for K times. For example, if K value is 3, we can consider only the 3 nearest neighbors. If k value is 5, we can compare only the 5 nearest neighbors. If k is 10, we can consider only the 10 nearest neighbors. Okay. Defining k can be balancing act as different values can lead to overfitting or underfitting. What is overfitting and what is underfitting? Overfitting is an undesirable machine learning behavior that occurs when the machine learning model gives accurate predictions for training data but not for new data. That is, overfitting means it will give accurate result for trained data, but it may not give accurate result for new data set. That is overfitting. Underfitting means it may not give accurate result for both training data and new data. Okay, underfitting means it it may not give accurate result for both trained data and new data, but overfitting means it will give accurate result for trained data but not for new data. Okay, let us see one classification problem. Find whether the new attribute 37 of a tissue paper will be classified as a good class or bad class. The given k value is 3. Let's see the table. The points 7, 7, 7, 4, 3, 4, 1, 4 are attributes of a tissue paper. And if the attribute is 7, actually it is 7, strength 7 means it is classified as bad class. 7, 4 means it is classified as bad class. 3, 4 is classified as good class, and 1, 4 is classified as good class. Now we are going to classify the tissue paper with attributes 3, 7 is bad class or good class. First plot all its attributes. Okay, in the xy space. Plot all its coordination points. Now find the distance from this new point to all other points using any one of the below techniques. That we have to find the distance from the new point to all the existing points. That is 3, 7. D1 is the distance between 1, 4 to 3, 7. D2 is the distance between 3, 4 to 1, 3, 7. D3 is the distance between 7, 4 to 3, 7. And D4 is the distance between 7, 7 to 3, 7. Now we are going to find the distance between these two coordination points by using the below techniques. What are the techniques? There are many methods are there: Euclidean distance, Manhattan distance, Minkowski distance, and Hamming distance. Now we are going to use Manhattan distance. What is Manhattan distance? Distance is equal to absolute value of x minus x2 plus absolute value of y minus y. This is the formula to find the distance between two coordination points. Let us find the distance of all d1, d2, d3, d4 by using that formula. So d1 equal to 5. Here the absolute value of minus 2 is plus 2, that is positive 2, and absolute value of minus 3 is positive 3. So d1 equal to 5. Similarly d2 equal to 3. Here absolute value of minus 3 is positive 3, right? So d2 equal to 3, and d3 equal to 7. D4 equal to 4. So the value d1 equal to 5, d2 equal to 3, d3 equal to 7, d4 equal to 4. Sort these distances and consider only the 3 closest neighbors because the given k value is 3. Short 3, 4, 5, 7. Ignore the last one. So consider only D2, D4, D1. So D1 equal to 5, D2 equal to 3, D3 equal to 7, D4 equal to 4, and D3 is ignored. Take the neighbors 3, 4, 5. What are the attributes of the distance 3, 4, 5? 3, if you take 3, the distance D2, attribute is 3, 4, good class. 4, 4 is the distance D4, attribute is 7, 7, already classified as bad class. See that first table. 5, distance D1, attribute is 1, 4, class already classified as good class. See the first table. So here one bad class and two good classes. Majority are good classes. So if classification, you should see the majority. If regression, you should see the average. Here this is a classification problem. So we should consider the majority. Majority is good class. So the received paper with attribute 3, 7 is classified as good class. Okay. And these are applications of KNN, data pre-processing, recommendation engines, healthcare, pattern recognition, finance. Advantages of KNN algorithm: easy to implement, adopt easily, few hyperparameters. Disadvantages: does not scale well, curse of dimensionality. These are the disadvantages of KNN algorithm. Thank you.